Imagine for a moment that the Earth is an enormous cosmic egg. This isn't just a whimsical idea. It's a concept that has fascinated humans for thousands of years. Ancient Egyptians, for instance, believed that the Earth was an egg guarded by the moon, which they saw as a great white bird, much like a goose brooding over her egg. The Gnostics, early Christian mystics, also saw the Earth and heaven as a world egg, cradled in the womb of the universe. This idea of the Earth as an egg, with a giant serpent entwined around it, warming and guarding it, was a powerful and universal metaphor that captured the imagination of many ancient cultures. In the 7th century, the Venerable Bede, an English monk, described the Earth in a way that echoed this ancient imagery. He wrote that the Earth is an element placed in the middle of the world, just like the yolk of an egg. Around it is the water, like the white surrounding the yolk. Beyond that is the air, like the membrane of the egg, and finally the fire, which encloses it all, much like the shell of an egg. This vivid description helps us understand how ancient people tried to make sense of the world around them using familiar, everyday objects. 1,000 years after Bede, Thomas Burnet, an English divine, wrote a celebrated sacred theory of the Earth in 1684. Burnet combined Platonic theology, science, and his experiences of alpine travel to create a comprehensive theory of the Earth's formation and transformation. He acknowledged that the idea of a mundane egg, or an egg-shaped world, was a common belief among many ancient cultures, including the Latins, Greeks, Persians, and Egyptians. Burnet's theory described the Earth's surface in 4 phases: creation, deluge, conflagration, and consummation. According to Burnet, after the deluge, the Earth dried out, and internal changes prepared it for a great burning. After this conflagration, a new heaven and a new Earth would emerge, leading to a millennium of peace and prosperity. Finally, the Earth would transform into a bright star, fulfilling all the prophecies in the scriptures. Before the Greeks began to believe that the Earth was a sphere, they debated other simple forms it might take. Herodotus, the ancient Greek historian, ridiculed the Homeric notion that the Earth was a circular disk surrounded by the river Oceanus. Instead, he argued that the Earth must be surrounded by a great desert. The idea of an equator, a line dividing the Earth into 2 equal parts, came even before the general belief in a spherical Earth. Herodotus believed that the Nile and the Danube rivers were symmetrically placed around a median line that ran through the Greek maps. This line, which followed the longitudinal axis of the Mediterranean, was thought to explain many natural phenomena, such as the ideal climate in Asia Minor, which lay along this axis. The concept of a square Earth also appealed to many ancient cultures. The ancient Peruvians imagined a box-like world with a ridge-shaped roof where their great god lived. The Aztecs saw their universe as a series of 5 squares, with a central square and one extending from each side. Each square represented one of the 4 cardinal points, all reaching out from the middle place, the dwelling of the fire god Xiuhtecutli, who was considered the mother and father of the gods. The Aztecs believed that this fire god lived in the navel of the Earth, a central point that was both spiritual and physical. Other ancient cultures saw the universe in different shapes. The ancient Peruvians imagined a box-like world, while the Aztecs visualized a series of 5 squares. Some saw the universe as a wheel, and others as a tetrahedron. These diverse ideas show how different cultures tried to make sense of the world in their own unique ways. One of the most universal and appealing metaphors for the universe was the world tree. The Vedic poets of ancient India explained that if a small tree could lift a rock as it grew, then a great tree could surely support the heavens. This led to the concept of the tree of life or the tree of knowledge, like the one in the Garden of Eden. Many cultures had their own sacred trees. In Norse mythology, the cosmic ash Yggdrasil was the greatest and most holy seat of the gods. The gods met in council every day under this immense tree, whose branches spread over the world and reached above heaven. The roots of Yggdrasil were wide and deep, with one root in Asgard, the home of the gods, another in the realm of the frost giants, and the third in the heavens, where the most sacred fountain of Erd was located. This tree was a symbol of the interconnectedness of the universe and the divine order that governed it. By the 5th century B.C., Greek scholars began to see the Earth as a globe. The first firm evidence of this belief is found in Plato's Phaedo. From then on, serious Greek thinkers stopped thinking of the Earth as a flat disk floating on water. The Pythagoreans and Plato based their belief on aesthetic grounds, arguing that a sphere was the most perfect mathematical form, and therefore the Earth must be spherical. To argue otherwise would be to deny the order and harmony of the universe. Aristotle agreed with this view for both mathematical and physical reasons. He argued that at the center of the universe, the Earth would naturally form a sphere as it came together from all directions. He also provided physical evidence, noting that the Earth's shadow during a lunar eclipse was always rounded, which could only be explained if the Earth was spherical. In Aristotle's lifetime, mathematical geography made remarkable advances among the Greeks. They still lacked detailed knowledge of the Earth's surface to create accurate world maps, but using pure mathematics and astronomy, they arrived at surprisingly accurate estimates of the Earth's size and shape. Classical writers, including great philosopher-scientists like Pliny the Elder and Ptolemy, as well as popular encyclopedists, assumed and elaborated on the sphericity of the Earth. This discovery was one of the most important legacies of classical learning to the modern world. The idea of a spherical Earth opened up new possibilities for the imagination. A sphere could be divided in many symmetrical and beautiful ways. The ancient geographers were quick to explore these possibilities. One of the first ideas was to encircle the sphere with parallel lines, creating zones or climata. These zones were not based on weather patterns, but on the angle at which the sun appeared in the sky. In the zone near the poles, the longest day of the year lasted over 20 hours, while near the equator, daylight never lasted more than 12 hours. In between were zones where the longest day lasted various lengths of time. Ancient writers disagreed on the number of such zones. Some thought there were as few as 3, while others saw 10 or more. The most popular scheme was Pliny's division of the part of the Earth known to the Greeks and Romans, up to 46 degrees north latitude, into 7 parallel segments, all north of the equator. He indicated 3 more zones for the wilderness farther north. Ptolemy increased the number to 21 parallel segments for the entire northern hemisphere. These arbitrary lines had a significant impact on how people understood the Earth's surface. However, they were not always accurate. For example, Strabo believed that the regions near the equator, where the sun was directly overhead for part of the year, had a unique flora and fauna. He described these areas as parched and sandy, producing only certain pungent fruits and the small terebinth tree, the source of turpentine. He also noted that the people in these regions had dark complexions due to the scorching sun, while those in the extreme north had light complexions and were considered savage due to the cold. The search for symmetry and the quest for understanding the Earth's zones led to the development of the Ptolemaic system of the Earth. This system, though less well known than the Ptolemaic system of the heavens, still forms the basis of our understanding of the planet. Herodotus and other early Greeks drew an east-west line through the Mediterranean, dividing their known world. This simple line was a crucial beginning in understanding the Earth's spherical form. Eratosthenes, one of the greatest geographers of the ancient world, made significant contributions to our understanding of the Earth. He is known mostly through hearsay and the attacks on him by his critics. Julius Caesar relied on his geography, and in Alexandria, Eratosthenes served as the second librarian of the greatest library in the Western world. A mathematician among geographers, he developed a technique for measuring the Earth's circumference that is still used today. Eratosthenes heard from travelers that at noon on June 21st, the sun cast no shadow in a well at Scene, modern Aswan, and was thus directly overhead. He knew that the sun always cast a shadow in Alexandria. By measuring the angle of the sun's shadow in Alexandria at the same time, he calculated that the sun was 7 degrees 14 from overhead, which is 1/50th of a full circle. This measure was remarkably accurate, as the actual difference in latitude between Aswan and Alexandria is 7 degrees 14. Eratosthenes then calculated the Earth's circumference to be 250,000 stadia, which is about 28,700 miles, or 15% too high according to modern calculations. Eratosthenes' technique for charting the Earth's surface was even more significant than his final calculations. He subdivided the Earth using parallel east-west lines and north-south lines, or meridians. He separated the habitable world into a northern division and a southern division using an east-west line parallel to the equator, running through the island of Rhodes and bisecting the Mediterranean. He added a north-south line at right angles, running through Alexandria. On his map, other lines were drawn through ancient, familiar, and prominent places, creating an irregular network that served human convenience. Hipparchus of Nicaea, one of the greatest Greek astronomers, took Eratosthenes' ideas further. He insisted on marking off all climata lines completely around the sphere, at equal intervals from the equator to the poles. He also marked off other lines at right angles to these, creating a regular grid covering the entire planet. These lines, when numbered, provided a simple set of coordinates for locating any place on Earth. Hipparchus saw the potential of using celestial phenomena to locate places on the Earth's surface, setting the pattern for man's cartographic mastery of the planet. Ptolemy, the father of modern geography, built on the work of Eratosthenes and Hipparchus. He is best known for his Almagest on astronomy, his geography, and his writings on astrology, music, and optics. Ptolemy's geography summed up the best thinking of his time, drawing on the work of Eratosthenes, Hipparchus, and Strabo. He acknowledged his debt to Strabo, who used tradition, myth, and his own wide travels to survey the known world. Ptolemy's work laid the foundation for modern cartography, using a grid of latitudes and longitudes to map the Earth accurately. Latitude and longitude were to the measurement of space what the mechanical clock was to the measurement of time. They marked man's dominance over nature, allowing precise units to be used for describing and locating places on the Earth's surface. These coordinates substituted precise measurements for the accidental shapes of the natural world, giving humans a powerful tool for understanding and navigating their environment. In conclusion, the idea of the Earth as a cosmic egg, a square or a wheel, reflects the diverse ways in which ancient cultures tried to make sense of their world. The development of the concept of a spherical Earth and the subsequent creation of a grid of latitudes and longitudes marked a significant step in human understanding of the planet. These ideas, refined over centuries, continue to shape our understanding of the Earth today. Whether we look at the world through the eyes of ancient Egyptians, Greeks, or modern scientists, the quest to understand our place in the universe remains a fundamental human endeavor.